Welcome back to the course on Principles of Behavioral Economics. This is lecture 45. Now we are discussing intertemporal choice models, and in the previous modules we have introduced the concept of intertemporal choice models and also the contributions that came from neoclassical economics, the discounted utility model. Now here we today going to discuss features of the discounted utility model. There are a number of features of the DUM that now need to be examined, since these relate to the implicit psychological assumptions underlying the model. First of all, integration of new alternatives with existing plans. Second, utility independence. Third, consumption independence. Fourth, stationary instantaneous utility. Number 5, stationary discounting. Number 6, constant discounting. 7, independence of discounting from consumption. Number 8, diminishing marginal utility and positive time preference. So, these are the features that we are going to discuss in the next. Beginning with the first one, integration of new alternatives with existing plans. It is a common assumption in most decision or choice situations relating to the standard model that people evaluate new alternatives by integrating them with existing plans. So, if we go back to the life cycle hypothesis, then you remember we said that whatever, if additional wealth comes, then that is integrated with the existing wealth and then again divided across all the periods one expects to survive or live, and then accordingly the consumption is decided. So, this is the basic idea behind integration of new alternatives with existing plans. So, this means that if a person is offered a prospect A, say investing $10,000 now to gain $15,000 in 3 years, the effects of this prospect on the person's whole consumption profile must be considered. Thus, if the person currently has the consumption profile, say Ct to small t to capital T any periods, then they must estimate their new consumption profile if they were to accept prospect A, for example Ct prime to Ct C capital T prime. So, basically there is an additional wealth that has been incorporated, and how it is going to change your consumption pattern, this is given by this new profile. Prospect A would then be accepted if the utility generated by this new profile is greater than the utility generated by the existing or old profile. Although this approach may seem logical from a normative point of view, meaning that people should want to integrate new alternatives in order to maximize welfare, however, this places unrealistic demands on people's mental capacities. We actually cannot predict or foresee future so well that we would be integrating all such possible income or additional wealth to our existing wealth and then decide how much to consumption or how much to consume. So, this is basically placing unrealistic demands on our mental abilities. People may not have well formed consumption profiles relating to all future periods, and they may be unable or unwilling to reformulate such plans every time that new prospects are encountered. The second one is utility independence. It is assumed in the DUM, that is discounted utility model, that it is simply the sum of all the discounted future utilities which is relevant in terms of making intertemporal choices. So, if you remember the expression, we have the total utility is equal to the first period utility, say denoted by U1, then the second period discounted utility, then the third period discounted utility, and so on. So, sum of all the future stream of utilities discounted. This ignores the possibility that the distribution of utilities over time may be relevant. As we shall see, people may prefer a flat or rising utility profile to a falling one, or a pattern of dispersion of utilities rather than a concentrated pattern. So, basically how I am expecting the utility or the flow of utility in the future, it might have a particular distribution, that is actually the DUM does not talk about. A related assumption is consumption independence. So, what is consumption independence? It is assumed in the DUM that a person's welfare in any time period is independent of consumption in any other period. This means that preferences over consumption profiles are not affected by the nature of consumption in periods in which consumption is identical in two periods. I am going to give you an example shortly. It is therefore analogous to the independence axiom in expected utility theory. For example, consumption independence says that one's preference between an Italian and Thai restaurant any night should not depend on whether one had Italian last night nor whether one expects to have it tomorrow. So, basically the idea is that my past decision may impact my current or future decision. So, if I am offered a meal in a restaurant, say Chinese restaurant, and if I had it just the night before or yesterday night, then I would like to have it after a couple of days if that is allowed. And if I am forced to have it immediately, maybe my satisfaction or utility would be somewhat lesser than if I would have been allowed to have the meal after a certain period of time. So, my past preferences or my past experience of course impact my present situation or preferences, choices, that is not taken into consideration in DUM. It should be noted that neither Samuelson nor Koopmans proposed that this assumption had either normative or descriptive validity. This gives rise to various anomalies in the model, which we will see later. The fourth one is stationary instantaneous utility. The DUM generally assumes that the instantaneous utility function is constant over time, meaning that the same activity yields the same utility in the future viewed from the future as now. So, instantaneous utility function means the utility is generated by a functional form which is given by or a result of what I am doing currently. So, suppose I am reading a book, the satisfaction that I am getting from it is my instantaneous utility. Now, it is quite possible that what I prefer to do today or the kind of satisfaction that I obtained by or from some activity today won't be the same day after 1 week, after 1 week, after 1 month, or maybe after several years. The assumption is that it remains constant in DUM, but it is not necessary that it will remain constant. For example, if activity A is expected to yield 20 utils, the unit of measurement of utility, in 3 years time, the current utility of A, which can be written as U naught A, will be discounted to about 15 utils at 10% discount rate. So, I apply a 10% discount rate, 20 is supposed to come in 3 years time. So, that is why I have 1 plus 0.1 raised to the power 3, which would be roughly identically equal to or approximately equal to 15. However, it is assumed that the utility of A in 3 years time, that is U3A, will still be 20 utils. So, if it is 20 today, then it is 20 after 3 years also. This implies that people's preferences do not change over time, which is an obviously unrealistic assumption. For instance, youngsters are very fond of going for movies. They go to watch movies in groups of friends and all, but as we age, consider a person in his 40s, 50s, 60s, 70s, their preferences for going for movies in groups or alone would be much lesser, which implies that utility from watching a movie has substantially decreased over a period of time. It is not the same, but then DUM assumes that it remains constant over a period of time. Evidence suggests that people tend to exaggerate the degree to which their future preferences will resemble their current ones, a phenomenon referred to as projection bias. So, when I am in 20s and I am very fond of watching movies, going to movies with friends, I would think that even when I will be in 40s or 50s, my preferences for going to movies with friends would be the same. But that need not be the case. So, I am suffering from or I will be suffering from projection bias, which we have already discussed in the previous module. Thus, we may expect to like the music trending today in 20 years because we like it now very much, but then we may find in 20 years time that we can't even stand it. The fifth feature that we are going to discuss is stationary discounting. It is assumed in the DUM that people use the same discount rate over their lifespan. Suppose A consumes C in each period. So, C is the amount of consumption. Then in addition to C, the decision maker is given the choice of consuming an additional x at time t or an additional x prime at time t prime. Now x prime is greater than x, which means that it is a, say, a larger quantity. So as alongside my consumption, I am offered at time period t, say, another consumption of another, say, 1000 rupees. It is easy to measure, and then I have this is in period t, and in period t prime, which is basically greater than period t. In the sense, if period t is tomorrow, then t prime could be day after tomorrow, and I am offered an amount which is like 1500. So the amount is larger, the time period is later. Alongside my existing consumption, these are offered to me. A will choose x at time t. What is happening here is that I am first of all summing up all the consumption present as well as future, excluding time t, and then in time t or for time t I have utility from C plus x, and then it is of course multiplied by the discount factor delta raised to the power t. A will choose x at time t if this is greater than this, and what is this? This actually includes all consumption that would be coming forward as well as the present consumption summed up, excluding the consumption in period t prime, and then this is the consumption in period t prime multiplied by its discounting factor, or the consumption in period t prime discounted to the present. So this is also present value considering t prime or consumption in t prime. This is also present value of consumption considering the option of consuming C plus x in time t. So if this is greater, then A will choose x at time t. This will be the case if delta t prime u c plus delta t u c plus x is greater than delta t u c plus delta t prime u c plus x prime. So what does it say? They simply say that we are retaining this, right, and if you compare these two terms, this term and this term, then the only difference between them is that here t prime is included and t is not included, here t is included and t prime is not included, right. So since all the other terms are same, I can cancel the rest of the term, retain delta t prime u c plus this exact term is greater than delta t u c, the rest of the terms are cancelled, plus delta t prime u c plus x. So if this holds, then this holds, and then A will choose x at time t. Now that this expression we had derived in the last slide. So now this expression can be reorganized like this. So what we are simply doing is that taking u c to this side, taking delta raised to the power t common, then we will be having u c plus x minus u c, this term, and then we are taking this to the other side. So we have delta t prime multiplied by u c plus x bar minus u c, right, and then when we have both the terms or in one side, then we will be having delta t prime, delta raised to the power t prime minus divided by delta raised to the power t, which can be written as delta t prime minus delta t. This is true for any value of t and t prime. The long t prime and t is constant. Thus, the choice between x or x prime depends on the interval of time that passes between the two possible dates of consumption, that is t prime and t, and not the point in time when x could be consumed. This property of DUM is called the stationarity property. Now let us take a small example. Suppose that the decision maker could choose x at time 0 and x prime at time 7. So she will choose to consume at time 0 if delta 7, which is basically the difference between t prime and t. Here this is 7 minus 0 equals to 7. So delta raised to the power 7 is less than this expression. If this is so, then the individual will choose to consume x at time 0. If this is the case, then she would also choose x if given the choice of x at time period 257 or x prime at time period 257 plus 7 264. So, again you see that does not matter whether it is 70 or say 37 minus 30 or say 264 minus 257. What are the time periods? The time periods themselves do not matter. What matters is the difference between the two time periods. The long it is 7, then delta raised to the power 7, if less than this expression, then the individual will choose to consume in period 0, will prefer x over x prime. However, she may choose x prime if given the choice between x at 257 or x prime at time period 260. Now, see, if it is 260 and 257, then t prime minus t is equal to 3. So, when the time period is different, then of course her choices can be very different. So, here if she chooses x prime over x, then this implies that 260 minus 257 u c plus x prime minus u c, which is equal to delta raised to the power 3 u c plus x prime minus u c. This is greater than delta raised to the power 7 multiplied by u c plus x raised to the power u c plus x prime minus u c. So, basically delta raised to the power 7. So, here delta raised to the power 3 multiplied by the difference in consumption is greater than delta raised to the power 7 multiplied by the difference in consumption, and that is why she preferred to choose to consume x prime instead of x. Thus, the choice between x or x prime depends on the interval of time that passes between the two possible dates of consumption. I am just repeating it, which is like t prime minus t and not the point in time when x could be consumed, in this case period 257. If preferences display stationarity, then the choice between two potential consumption bundles does not depend on the time they are offered, only upon the interval between possible consumption dates. So, this is basically the concept of stationary discounting. In contrast, there is considerable evidence that discounting rates vary according to age. For example, Michel and Metzner have found that willingness to delay gratification increases with age, implying that older people have a lower discount rate. However, the relationship between discounting and age appears to be a complex one. In an experimental study of respondents between the ages of 19 and 89, it was found that older people discount more than younger ones and that middle-aged people discount less than either group. Similar results were found and confirmed by another study in 2002. A more detailed study in 2013 introduced two further parameters into the relationship between discounting and age, that is cognitive ability or impairment and gain or loss. Their conclusions suggest an even more complex situation, since they had found that both cognitive impairment and losses versus gains are relevant to discount rates. For gains, they find that middle-aged subjects discount at the same rate as older impaired subjects, while older unimpaired subjects discount at a lower rate than either of them. The picture is somewhat different for losses. In this case, middle-aged subjects discount at the same rate as older unimpaired subjects, while older impaired subjects discount at a higher rate than either of them. Thus, it appears that older impaired subjects discount both future gains and future losses more highly than unimpaired subjects. It should be noted, however, that this is not irrational given the shorter expected lifespan and lower quality of life of such subjects. Now, here I would just like to clarify one thing. What is meant by when we are talking about discounting at a higher rate or a lower rate? For example, when we say older impaired subjects discount at a higher rate than either of them. So, in order to explain that, I will just give a small example. Suppose I ask you, what would you like to have? Would you like to have 100 rupees today or tomorrow? So, my first question is that you want to have 100 rupees today or tomorrow. So, suppose somebody says that I want to have it today, which implies that 100 rupees today is not equal to 100 rupees tomorrow. The preference is strictly in favor of 100 rupees today. Now, if I ask that individual that how much would you like to receive in order to be indifferent between 100 rupees today and 100 rupees tomorrow. So, suppose that individual says that either you give me 100 rupees today or you give me 110 rupees tomorrow. So, for that individual 100 today is equivalent to 110 tomorrow, which implies that he is actually having a discount rate of 10%, because 110 divided by 1 plus 0.1 is equal to 100. Now, suppose another individual says that no, I want 100 today, or if you want to delay it, I want 120 tomorrow. So, for that individual 100 today is equal to 120 tomorrow, which means he has a discount rate of 0.2. So, this individual is actually applying or discounting the future at a higher rate, higher discounting rate. These kind of individuals are said to be more impatient. A patient individual will have a smaller discount rate, in the sense that someone is still willing to wait. Larger the interest rate, or the discount rate, the more impatient the individual is, and this is what is implied by a higher discount rate or a lower discount rate. Next, we talk about constant discounting. The DOM assumes that at any period of time the same discount rate is applied to all future periods. In mathematical terms, this means that given the discount function, that is, this is the discount function we already introduced in the previous modules, at time period t, the same per period discount rate rho is applied to all the periods in the future. So, your discount rate remains constant. Now, a close concept is that of stable discounting, which also has the same implication. Consider the problem of choosing between two consumption profiles. These are the two consumption profiles. You can see that current period consumption remains at C1, because we are at the current period. We are beginning with the current period as 1, period 1, and in future the consumption profiles are going to change. The consumption or the amount you consume in period 2 and 3 are different. In the first period, the person would strictly prefer C if utility from consumption in the first period, then utility from the consumption in the second period discounted to the present value, utility from the consumption in the third period again discounted to the present value is greater than similarly the present consumption and consumption in period 2 and 3 discounted to the present value. Now, here you note that we are not using delta raised to the power 2 or delta raised to the power 3, because all we want to show is that whether the delta, or you know that delta is equal to 1 upon 1 plus rho. So, if delta is constant, rho is constant, or if rho is constant, delta is constant. So, we want to check whether rho and delta are constant or not, and that is why we did not mention delta raised to the power 2, because if we mention delta raised to the power 2, that automatically assumes that rho and delta are constant. Now, from this expression we can always write this expression, where basically we have changed terms and arrived at this expression, where delta 3 divided by delta 2 multiplied by the difference in the consumption in the third period is greater than difference in the consumption in the second period. So, this is happening if the person prefers profile C. In the second period, the person would strictly prefer C if and only if, again, that is, I have arrived in the second period. Now, second period is my current period. I am consuming UCT multiplied by delta UC3, which is basically the consumption in the next period discounted by this discount factor, and again that is greater than the alternative profile. So, if this is greater than the alternative profile, then I will be preferring consumption profile C. Now, again rearranging terms, I will be getting delta 2 multiplied by the difference in the consumption in period 3 greater than the consumption in period 2. Now, equation 1 is reproduced here for ready reference, and 2, this is this equation, are always consistent for delta 3 equals to delta 2 square. Now, you can see that this term and this term are same, the right hand side is also same. So, we will be having both of them valid if this equals to this, which implies delta which implies delta 3 upon delta 2 equal to delta 2, that is delta 3 equals to delta 2 square. So, if utility in period 3 is discounted by the square of the discount factor applied to period 2, then preferences will always be constant and the decision maker will never regret the decisions she made in previous period. If this equality does not hold, then we cannot guarantee consistent decision making across time periods. Therefore, this condition ensures time consistent preferences, since the standard model views time consistent preferences as being rational and inconsistent preferences are usually seen as irrational. This feature of the DOM is often perceived to be legitimate. However, there is a plentiful empirical evidence that discount rates are not constant over time, but rather tend to decline. Inconsistent time preferences have been widely observed. This evidence and alternative models of accommodating it will be seen later. It should also be noted at this stage that constant discounting is not a sufficient condition for consistent time preferences to exist. Stationary discounting is also necessary. If discounting is not stationary, then in the following time period, that is t plus 1, one may observe the different but still constant discount function, which is like this. Here we are having 1 upon 1 plus rho prime, this is raised to the power k, where rho prime is not equal to rho. For example, the evidence in the study with older people mentioned above suggests that as people enter middle age, rho prime becomes less than rho. As I was trying to say, that a smaller value of rho implies that we tend to become more patient. In this situation, discounting is constant in both periods t and t plus 1, but the discount rate changes with the passage of time. The consequence of this is that once again time preferences will be inconsistent. So, next we talk about the seventh feature of independence of discounting from consumption. Another assumption of the DOM is that all forms of consumption are discounted at the same time. Without this assumption, it is impossible to reduce the discount rate to a single parameter or to talk about a uniform time preference. As Frederick Lowenstein and O'Donoghue put it, we would need to label time preference according to the object being delayed, like banana time preference, vacation time preference and so on. So, what they say is that for each and every good or service that we consumed, we might have a very different time preference in terms of delaying things or preponing things. There is indeed evidence that different products are discounted at different rates, even that different attributes of products are discounted differently. A 2004 study found that perceived effort and perceived price are discounted differently. Do-it-yourself products involve effort in terms of consumption and appear more attractive when the purchase is planned for some time in the future. When purchase is immediate, such products appear less attractive, implying that perceived effort is discounted more heavily than price. Once again, the consequence is that preferences are inconsistent over time. And finally, the last feature of diminishing marginal utility and positive time preference. Although these two features are not essential elements of the DUM, in practice most analysis involving intertemporal choice assume that both conditions exist. In actuality, both elements predate the DUM, since Fisher in 1930 emphasized the importance of each of them in his indifference curve analysis approach. Indifference curves generally require the assumption of diminishing marginal utility or concave utility functions. These things we discussed while discussing DUM. The implication of this condition is that it might cause people to delay consumption until later time periods. For example, when we eat a delicious and generously portioned meal, we may prefer to leave some of it for the next day, or if at a restaurant, take the remaining portion home in a doggy bag. It should be noted that this effect of diminishing marginal utility operates in the opposite direction of the normal direction of time preference, because generally we say that we have diminishing marginal utility with respect to time preference also. So, if I just had a meal despite of how delicious it is, I would not actually prefer to have it in the next meal time. So, because my marginal utility is diminishing. But when we carry the leftover home or we save something for the next time, then this actually violates the assumption of diminishing marginal utility. Normally time preference is positive, meaning that people apply a positive discount rate to future utilities. For this reason, many economists have not been happy with Fisher's approach on the grounds that it confounds the effect of diminishing marginal utility with pure time preference. However, we shall see later that it is very difficult to define the term pure time preference, since there are in reality a number of confounding factors all the time, not just the phenomenon of diminishing marginal utility. With this, I conclude this module on the features of DUM. In the next, we are going to discuss the anomalies that are observed in the applications or in the context of DUM. Thank you.